Okay, so I'm going to be working through this video to help. I'm going to use this worksheet to kind of help explain better the connection between average rate of change and instantaneous rate of change. I've been reading the discussion questions, and there still seems to be some confusion. So first of all, we need to know that average rate of change is always done over an interval. So you can't talk about the average rate of change at a point on the graph or an average slope at a point on the graph. You have to talk about the average rate of change over an interval from, x value to x value. So in this case, it says use the values in the table to estimate the following. So this is asking you, remember t prime of 1.4, that the prime means derivative, which means this is asking for an instantaneous rate of change or an instantaneous slope at 1.4. So this is asking when x is 1.4, how steep is the graph of t, or what is the slope of the graph of t? Okay, so because we don't know what the equation of t looks like, we can't really use the method we know to find the derivative, so we have to estimate it. We estimate it using average rate of change. So now because 1.4 is sitting right here, we can use a number of different things to estimate it. We could use this interval right here from 1 to 1.4. So then that would look like this, 2.2 minus 1.06 over 1.4 minus 1. And of course, you could calculate that and get the slope. Or you could use from 1.4 to 1.8. So that would be 3.2 minus 2.2 all over 1.8 minus 1.4. That would also give you an estimation for that slope. And actually, for that matter, you could use the whole interval from 1.8 to 1.0. So that would be 3.2 minus 1.06 over 1.8 minus 1. All of these would be estimations for t prime of 1.4. In fact, if you want to do the best one, you might just average all of them or something. Find all three and average them. But all of these are decent approximations for. They're not the actual slope at 1.4, but they're approximations for it. Okay. So then when you look at the same question with 2.4, of course, we have less options here because there's only one interval that actually contains 2.4, at least one small interval. So the obvious choice for here to estimate this would be 3.1 minus 2.8 over 2.6 minus 2.2. And of course, you'd simplify that. So that's the idea of we're using average rate of change to approximate instantaneous rate of change. Now, if we step down here, this is a whole nother idea that you were just introduced to the definition of derivative. So when you see this, you should recognize that this is just asking the same thing it did up here. Because you can see that this is t of something plus h minus t of the same something over h as h approaches 0. So this is the slope of the secant line, and the limit of as h approaches 0 makes it become the slope of the tangent line, right? So this would be the same answer as whatever I got for up there. Okay, so now I'm going to skip down here a little bit. Oh, here we go. Equation of the tangent line. This is probably a good one to pause at. So if I'm trying to find the equation of the tangent line at x equals 1, that means I go back up here, and at x equals 1, I need to come up with a slope for that. I don't know. I can't find the actual slope, so I'll have to approximate it. So first I would say t prime of x is approximately, and let's see, that would be what? 2.2 minus 1.06. So that'd be 2.2 minus 1.06 over, and what was it? 1.4 minus 1.0. 1.4 minus 1.0. So that would give me the approximation for the slope at x equals 1. Let's see, what would that be? That would be 1.14 over 0.4, which would be 114 over 4, or 57 over 2. So the equation of the tangent line is going to be y minus the y-coordinate. What's the y-coordinate at 1? 1.06. So that'd be y minus 1.06 is equal to the slope, which we just said was 57 over 2, times x minus the x-coordinate, 1. So that would be equation of the tangent line. Okay, down here is another point. This is kind of getting more detailed at what is the derivative. So the values of the derivative, f prime of x, are given in the table. So f prime, so this, now the table is giving me the values of the derivative rather than the original function. So now I'm supposed to use that table to estimate the following. So remember, what this is telling me is that when x equals 12, the rate of change of the function is 2, which we could think of that as 2 over 1 if you liken it onto slope. So that means every time I go over one x value, I'm going to go up 2 y values. This then at 12.4, it's steeper, you can tell, because it's every time I go over 1, I go up 3. And when I get to 13, it's even more steep. Okay, so the idea is we can use this slope to predict what the next value might be. So since I know that I was sitting at 8 when x is equal to 12, so in other words, this says that when I plug in 12 into the function, I get out 8. So this says if I go to the right, if I go over 1, I'm going to go up 2. That's what that's telling me. So that would say if we base our, if that makes sense, I mean, if we're going to use that to estimate it, that would tell me that this would be 10, wouldn't it? If I'm just basing it off of that number right there. Because it says if I go over 1, I should go up 2. So I went over 1, which means I should go up 2. Okay? But we're not going to do that because we actually have even some better information. So what we'll do is just kind of one at a time. Let's say we'll use this 2 to go from 12 to 12.4. So that means normally if I go over 1, I go up 2. But in this case, I didn't go over 1. I went over 0.4, right? So I'm trying to find out what that would be. So that means that, let's see, 0.8 is equal to x. So if I go over 0.4, I should go up 0.8. So that would make this 8.8. And then I could also use, now I'm going to use this new thing. This says when I get to 12.4, the slope is 3 now. So that means when I go over 1, I'm going to go up 3. Okay, so I'm going to use that to predict this value over here. And so I noticed that from 12.4 to 13, I'm going to go up 0.6. And I'm trying to find out how much I should go up in the y direction. So that's going to be what? 1.8 is equal to x. So then I would add 1.8 to this. So that'd be 9. So I'd add that to 0.8. And that would be what? 10.6. So my prediction is this would be 10.6. So that's using the derivative to approximate values of y. Okay, moving right along. Okay, I'll camp here for a little bit, but it says let f of x equal 10 to the x. Now we're supposed to estimate f prime of 1. So again, they're asking you to estimate it, give your answer to 4 decimal places. So the numerical approach just means I'm going to try smaller and smaller intervals. So I might say, let's do 10 to the 1, because we're valuing at 1, minus 10 to the 0.9 over 1 minus 0.9. And we calculate that slope. And then we might try 10 to the first minus 10 to the 0.99 over 1 minus 0.99 and calculate that slope. And then we might try 10 to the first minus 10 to the 0.999 over 1 minus 0.999 and calculate that slope. And in theory, as this value gets closer and closer to that value, these values should get closer and closer to what we're looking for. So that's the numerical approach, where I'm just kind of doing that limit process, but I'm actually doing it by plugging in smaller and smaller intervals. I'm making the h approach 0, so to speak. Okay, now down here, this says use algebraic approach. So this would be, I'm going to use this limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. And only we want x to be equal to 2. So that's going to be the limit of 1 over 2 plus h squared minus 1 over 2 squared all over 2 plus h minus 2 as h approaches 0. So see how I'm in this thing right here, I'm replacing x with 2, and I'm replacing f with 1 over s to the g. Okay? So let's see, that would be the limit as h approaches 0 of 1 over 2 plus h squared, I'll just leave that alone, minus 1/4 all over, of course that's just h because 2 minus 2 is 0. It's a complex fraction, so I'm going to multiply top and bottom by common denominator, and so I'm going to multiply by 2 plus h squared times 4, 2 plus h squared times 4, and I get the limit as h approaches 0. Now, of course, this times that is going to leave me with just 1, or sorry, 4, minus, and here the 4's are going to cancel out, and that's going to leave me with 2 plus h squared. And the bottom, I'm going to have 4h times 2 plus h squared. Okay, so then on top, I'm going to have 4 minus, if I multiply this out, that would be 4 plus 4h plus h squared, and I still have 4h times 2 plus h squared on the bottom. So notice up here the 4's are going to cancel out, and I'm going to be left with a factor of h. So I can factor out an h, so I'm going to cancel the h and the 4 minus 4, and I'll end up with, so those cancel out, and I'm left with a negative 4 minus h over 4 times 2 plus h squared. So the h here canceled out with that h and one of those h's, and this minus made that negative and that negative. So now I'm going to let h approach 0. Of course, when h approaches 0, this becomes 0, and that becomes 0, and I end up with a negative 4 on top, positive 4 on the bottom, and times 4, because as h approaches 0, this whole thing gets close to 4, so we end up with negative 1/4, because those 4's will cancel out. So that means g prime of 2 would equal to negative 1/4. Okay, so that's there is solutions to this answer sheet on Canvas too, but this, hopefully my explanation as I went through this will help you a little bit more with the understanding of what a derivative is, as opposed, which is a instantaneous rate of change, and how that compares to average rate of change.